Today, we will be expanding on our discussion about elements. Remember, the ancient Greeks proposed that there were four elements: water, fire, earth, and air. Now we have a better understanding of what elements are. However, there were key ideas from the Greeks that still hold true today. As we proceed today, consider this question. What properties ascribed by the Greeks to atoms do we still consider to be valid? A fundamental belief the Greeks thought was that the shape of atoms determines their properties. For example, water and iron would be composed of different elements with differing shapes. What shapes do you think the ancient Greeks ascribed to the elements water and earth? Earth being represented here as iron. The Greeks may have concluded that water molecules are spherical, since water molecules can slide over one another as it flows. Iron exists as a solid, so the Greeks may have proposed iron atoms would have spikes to help the iron atoms stick together. We now know that these aren't atoms. They are groups of atoms, and that the Greeks were describing macroscopic properties. In order for us to observe these macroscopic properties, we have to have macroscopic samples. Although we know today that these ideas are not correct for atoms, they foreshadow an important idea in chemistry, that molecular structure determines properties. Essentially, what determines a material's properties is not the shape of the atoms, but the shape and the structure of the molecules that comprise that material. For example, snowflakes have a hexagonal shape, or you could say a six-fold axis of symmetry. Notice how each of the snowflakes here have 6 points. At a molecular level, ice also exhibits this hexagonal symmetry. It is that molecular structure that determines the macroscopic properties of ice. We need to study chemistry to better understand the molecular origin of the macroscopic properties. So, what properties ascribed by the Greeks do we still consider to be valid? That matter is composed of atoms that are in constant motion. We have simply refined out views of what atoms are. Atoms are not small units of water, fire, earth, or air elements. However, the atom is the smallest unit of an element, and there are 118 elements that are currently known. The elements with greater than 91 protons, however, are man-made. Elements are arranged on the periodic table, like one shown here. For this class, the periodic table is to be used as a tool, not as something to memorize. The periodic table is an organizer of information about the elements. We will come back to this later in the semester to learn how to use the periodic table to gain information about the properties and reactivity of different elements. Until then, remember that the periodic table is arranged the way that it is for a reason. Remember that an atom is the smallest unit of an element. So what is different about the elements? They have different properties. For example, atoms of each element have different masses. Remember that atoms are comprised of protons, neutrons, and electrons. Well, atoms of each element have different numbers of protons. For example, all carbon atoms have 6 protons in the nucleus, and that is what makes them carbon.